Hey guys, hope everybody's doing okay. What I want to do right now is take a look at how we would solve a chemistry word problem. Okay, so word problems often intimidate students, and they don't really know where to start or how to approach them. They get, like I said, very intimidated by it, but it doesn't really need to be that way. So on your note sheet, you guys have a section at the top where it gives you the steps and the process for how to solve one of these. What I want you to do is take a second and copy that down, and we're going to use that set of steps to go through this practice problem. So the practice problem I have here is a density problem, so we'll look at some of those. This one's pretty tough actually. We'll have to do a couple different things to solve this. Some of them that you will practice on or practice with will be easier than this, and some will actually be a little bit more difficult. But we want to make sure we know how to go through this process and keep our thoughts and work organized as we go through it. So you might be able to look at this and solve it without showing much work, but I need to make sure I see your thought process and the steps that you're taking to solve this thing. In case you do make a mistake along the way, I can give you partial credit for that. Even in general, if somebody else looks at your work or looks at your paper and they see an answer, they want to know how you got that, okay? This is the process that we're going to go through to show all that. So our problem says, how much space is occupied by 3.17 gram per milliliter object if the mass is 2.7 kilograms. So the first thing we need to do is make a data table. Step number one. This is how we organize what's given to us in the problem. So it's just a repeat of what's given to you in the problem in a more organized fashion. So it says list and label what you know. So I underlined what we know here. So let's make a list and label it the right way. So we have a 3.17 gram per milliliter object. So you need to recognize that grams per milliliter is a unit, right? It's a unit of what? Because it doesn't tell you here. You need to recognize that it's grams per milliliter. That's a mass divided by volume. So we have a density, okay? So I'm going to label my density of the object as 3.17 grams per milliliter. Okay, so you should do the same thing. Notice how I have the capital D for density and the O for the object. Okay, that's important because sometimes we're not always going to have the same thing. So you might have densities of two different items. So it might be density of item A or density of item B, right? So make sure that it is organized and labeled the right way. Something else that's given to us, we have a mass of 2.7 kilograms. So let's label that. Okay, mass of the object, 2.7 kilograms. What else do I need to put in this list? Well, underneath step one, it says list what you're looking for. So I read through the problem and I'm looking for how much space is occupied by that object. What is what's the definition of for how much space something takes up? Well, that's volume. Okay, we don't know what that is. I want to know how much volume that object takes up. Okay, that takes care of our data table. All right, you get a point just for doing that. So sometimes students say, I don't know where to start. I don't know how to do this. First thing I say is, where's your data table? Where's your organized start to this problem? Because once you get your data table, I'm like, oh, look, I have density, mass, volume. I go to step two on my list, and step two says write down any relevant formulas. Okay, well, we don't have that many formulas in chemistry, at least so far. So one of my relevant formulas is definitely my density formula. So let's write that down. Okay, density equals mass divided by volume. So that is a relevant formula here. Another way to write this, because it goes on along to step number three, is to rearrange the formula. So I don't want to solve for density. Okay, I want to solve for volume. So how do I do that? You want to reorganize this so you get V equals whatever, not D equals M over V. Okay, um, fractions here, right? Students get messed up with fractions all the time. Okay, this is a very, very, very common mistake. So I'm going to help you avoid that. Another way to rewrite this formula, D equals M over V, is like this. Okay, minor difference there, but D density could really be written as D over 1. So D over 1 equals M over V, right? So density equals mass over volume. It's still what we have. But if you wanted to, and you want to clear that fraction out, What's a way to simplify that where you have a fraction equal to another fraction? Well, you can cross multiply. Okay, so cross multiply, and let's see what we end up with here. So if I cross multiply, I have d times v equal to m times 1, which is just m. Okay, this is a formula that this is another version of the density formula that you'll use at some point in time. So you could solve, like, the density formula is density equals mass over volume. That's obviously solving for d. You could have density times volume equals mass. Okay, and you still have another version of this. Okay, I want to solve for volume. So how do I do that? I have d times v equals m. I could divide both sides by density. Density cancels out, and I'm left with v equals m over d. Right? That is another one of my versions of this equation. Okay, that's the version I want to use for this problem. Okay, so I have my volume, or I have my mass right here. I have my density right here. So I have my two parts of this fraction. Now I could easily solve for volume. All right. So let's take a look at this and let's plug some numbers in. So we did step 3. It says don't plug numbers yet, rearrange first. So you have to do that. And trust me, this is a step you don't want to skip. All right, I see it all the time, year after year. You know, students try to plug numbers right into this version. They do their algebra incorrectly, and they end up with the wrong answer. All right, so please rearrange your formula. This, I mean, look how simple that is. This is as tough as a lot of the algebra is going to get right now. So you guys can handle that. Step 4 is to plug in the values. The values include a number and a unit. That is so important. You can't just cut corners here and skip out on the unit. You'll see why in just a second. All right, so let's plug in what we have and let's see what we end up with. So volume equals my mass, which is 2.7 kilograms, divided by my density, 3.17 grams per milliliter. Okay, notice how I plugged in my values, which is a number and a unit, okay, and that unit. If you look at the units that I have here, you should notice something, and something you notice hopefully isn't, like, it's not a good thing, okay? Look at what you have in the numerator. You have kilograms. Look at what you have in the denominator. You have grams per milliliter, but you have grams here. Okay, so that's not good. Any unit of, like, kilogram is a unit of mass. Gram is a unit of mass. That's the mass. That's the mass over volume, unit here for our density. That should be the same as that. So what do you have to do? You have to fix it. You could either convert kilograms into grams or grams into kilograms. This is it's a unit with two parts to it. It's a little more difficult or confusing to change this unit. So let's just change this one instead. So you can do it over here on this side of your T-chart, or you can do it over here. Sometimes I like to just do it right over there in the data table and then bump it over to the other side. Okay, so I'm going to do that for you guys. We're going to convert kilograms into grams. Let's knock that out using the factor label method. Okay, 2.7 kilograms times 1,000 grams over 1 kilogram. If we factor label that, kilograms cancels. All right, and we end up with our new mass, right? So 2.7 times 1,000, we end up with we end up with 2,700 grams. Okay, so that's going to be our new mass. And now let's plug that into our equation on the right-hand side. Okay, I'm going to ignore that because I want to make sure I clean it up here. Oops. I still have the old number there, 2,700. Let's make sure we get rid of that. Get rid of that decimal place there. Okay, 2,700 grams over 3.17 grams per milliliter. Okay, last step. We're basically almost done here. Number 5 says calculate the units of your answer. And of course, we want to calculate the number part of it as well. So you can take 2,700 divided by 3.17. So let's actually do that. We have to keep track of significant digits here, right? So let's do that. 2,700 has how many significant digits in it? It only has 2. The zeros don't count because there's no decimal place. 3.17 has 3 sig figs in it. So we're dividing, so we follow our division rules. We need to make sure we have 2 sig figs in our answer. So 2,700 divided by 3.17 gives us 851.7. All right, I need to round that to 2 significant digits. So there is 1 significant digit. Here is my second significant digit. The number after it is a 1, so I won't have to round it. So I'm going to end up with 850. Okay, that's the numeric part of my answer. Now, how do I simplify that unit part? Students get confused by this too. Let's take this unit component and solve for it. Simplify it. So we end up with grams divided by grams per milliliter, right? Okay, how do we simplify this a little bit? Let's rewrite that as a complex fraction. Okay, so you could rewrite grams over grams per milliliter as grams over 1, because you could rewrite grams at the top here as grams over 1. So grams over 1 over grams per milliliter. Multiply by your reciprocal, you end up with grams over 1 times milliliters per gram. It's the reciprocal of this bottom fraction, right? Look what happens. Grams cancel out, and you're left with milliliters as your final unit, okay? Students look at this, and they're like, okay, grams cancel, and they're like, well, you have like milliliters still on the bottom of the fraction here in this part of the unit. Well, how do you, like, what does that mean? How do you simplify that? This is the easiest thing to do. All right, so anytime you have a mass divided by a density, the mass component should cancel right here. Okay, you should be left with the volume component, which is what you have. You had to change kilograms from the 2.7 into grams though, because if you didn't, you wouldn't get grams canceling out with grams. You'd still have grams and you'd have kilograms here and grams here. You wouldn't be able to cancel it out like that. So the small details are very important. So let's put the two components together here. All right, 850 milliliters is your answer to this problem. Okay, this would be worth a ton of points, on a test or a quiz. So you definitely get a point for your data table, a point for your equation, a point for reorganizing it. So you're at 3 points already. You're going to have to change this into grams, another point there. So you're at 4. Got to show your work. That's 5. Your final answer with the unit is 6. Okay, so we're at least at 6 points for this whole process. If you don't show any of this work and you just show up with 850 milliliters on your paper, you're going to get 1 point out of 6. Okay, so it's not just getting the final answer. I mean, of course, that's important. It's the process you go through along the way. All right, so the expectation for this class is every time you have a word problem, you have a T-chart set up, okay, like you have on your notes. You have a data table, okay? You have formulas and work, okay? You rearrange it like it says on the right side of the screen. Plug your numbers in with units, okay? If you just had 2,700 divided by 3.17, you're losing points because there are no units there. I need to see that. Students don't put the unit, they don't recognize that one's in kilograms and one has grams here. So they never change it and they get the answer wrong. So everything I do here is for a distinct purpose, all right? Um, simplify everything, go to proper sig figs, and you're good to go. All right? All right, guys, you can work on some practice problems. We'll be good to go. Thanks.